Welcome, everybody, to the Stewardship Network's monthly webcast. My name is Rob Luzinski, and I am the community coordinator with the Stewardship Network. We will just wait a few moments here for everybody to join us. In the meantime, I'd like to welcome all of you and to invite you to utilize the chat if you'd like to introduce yourself with your name and your organization and where you're tuning in from. I can do my example, Rob Luzinski here with the Stewardship Network, and I am tuning in from Detroit, Michigan. There you are. All right. Wow. And it's looking like a great group today. Thank you all for joining us once again. Autumn, Brad, Clay, Dan, Garrett, Isabel, Lars. Nice to see you, Lars. Lisa, couple Lisas. Tina Stevens, nice to see you. Kyler, great to see you again. Forgive me that I can't mention every single person in here, but we've got a great group of folks today. Really excited to kick things off here. And with that, so one last reminder I'll say is please utilize the chat throughout the presentation for any comments or links or other resources you'd like to share. But we do ask that you utilize the Q&A section within Zoom for all of your questions so that we can keep track of them. We will save those until the end of the presentation. And if you have anything really pressing, let us know in the chat and we'll do our best to remedy that for you. So with that, welcome to the Stewardship Network's monthly webcast for January 2024. So first, a little bit about us. The Stewardship Network is a 501c3 nonprofit organization with an award-winning 20-year history. We are now serving 20-plus place-based TSN member communities from the Great Lakes to the Pacific Ocean. And our free TSN webcast happen on the second Wednesday of each month at the Eastern Time Zone's noon hour. Our mission is to connect, equip, and mobilize people and organizations to care for land and water in their communities. We mobilize folks through our TSN member communities. We make collaborative ecological stewardship accessible to all. We equip these member communities by removing hurdles so that they can pour thousands of annual work hours into their ecosystems. And we connect the specialized knowledge we've collected from and for TSN member communities, and we share it as widely as possible. One great aspect of the way that we connect folks is through our annual conference that's coming up this month, January 29th and 30th. And we'd love for you to visit stewardshipnetwork.org/conference to learn more. We've got a great agenda there for you to check out, and we've got some discounts running for a limited time. So we encourage you to register as soon as you can. And in fact, our presenter today will be a part of that conference. So we're excited to have a double dose. So another exciting development with regards to the conference is that we have been approved by MDARD pesticide and plant pest removal for 11 sessions at this year's event for seminar recertification credits. You can visit our website at stewardshipnetwork.org/conference and navigate to the agenda, and you can find more information about which sessions are approved for the MDARD credits and for what category they are approved. So we're really excited. Thank you so much to MDARD for approving these sessions, and we hope that our professionals in the audience will find that useful in their continuing education requirements. Advanced registration discounts end on January 21st, so we encourage you to get your tickets now, save a little bit of money, and it also helps us with our planning for the conference to get that done as soon as possible. And in other exciting news outside of the conference, we are so excited to welcome Columbia River Gorge Stewardship Network, our newest TSN member community out in the West Coast. We are extremely excited to have more of a presence out there, and just wanted to welcome this great new member community to the fold, and excited to tell you more about the great work that they do as they continue to steward their native ecosystems in their geographic area. Got to say it, meeting the match. We did it, folks, with all of your help, and we could not have done it without you. But our extremely ambitious Meet the Match campaign of last year, meeting $250,000 matching, that is no small feat. and we were able to do it. We met the match and then some. And so we are just need to appreciate and thank all of you so much for all of your support. We cannot do this work without you, and all of your support helps us continue to do the work that we do, to help connect, equip, and mobilize people and organizations to care for land and water in their communities. So it is with deep appreciation that myself and the rest of the Stewardship Network team thank you for helping us meet our match. We are so appreciative of you. And look at that. Oh, that is just a visual representation of the emotions we're feeling right now for you. So without further ado, I would like to introduce Jesse Lincoln, who is an ecologist with the Michigan Natural Features Inventory. And today, Jesse will be talking about identifying recoverable fire-dependent systems in the Huron-Manistee National Forest. So with that, Jesse, I'd love to invite you to share your screen and start the presentation.
How's it going? How's it looking?
It is looking good.
Great. Well,
now it's all loaded up. Great, thank you.
good. All right. Well, I'm very excited to be here. I'm a big fan of the Stewardship Network and looking forward to the conference. So yeah, very happy to be here. I'm also very excited to share this work. So identifying these recoverable fire dependent systems on National Forest has been really exciting, and it's been a really rewarding project, and so I think an important one to share. So real quick background on MNFI, Michigan Natural Features Inventory, where I work. Our mission is to guide the conservation of Michigan's biodiversity by providing the highest quality scientific expertise and information. We develop and deliver critical knowledge to a broad array of end users to provide awareness and literacy about Michigan's biodiversity and foster the conservation and stewardship of Michigan's natural heritage for the common good. And so we do this by maintaining a natural heritage program that consists of ecologists, zoologists, botanists, planners, and GIS specialists. We maintain this natural heritage database, which is this image of Michigan, which has informational location on all sorts of rare plants and animals around Michigan. We conduct surveys and inventories. We do research, monitoring, and modeling. We help with conservation planning and also help with conservation education. One of the areas that we've really been focusing on lately in the last few years is the application of prescribed fire. So fire was a major part of the landscape for millennia, and many of our natural communities are adapted to the application of fire. Fire maintains open structure, fosters regeneration of fire-dependent species, increases cover of native grasses and flowering plants or forbs, and it stimulates seed germination. This also maintains critical habitat for many species that depend on these more open prairie or savanna systems. In the past 2 centuries, we've enacted sort of widespread fire suppression, and that's for a number of reasons. But this loss of fire has caused the loss of the systems that depend on it, logically. And we've seen this conversion from these, in a lot of places, these open savannas to closed canopy systems, decline in fire-dependent species, and reduction in species and habitat diversity overall. So on the left, we have barrens and prairies and savannas around their extent and distribution around 1800. And then currently, this is the map of those that remain. So we've lost like 99.9% of these fire-dependent systems in the past 2 centuries. And with it, the species that depend on these places. To address this, some of my colleagues, Josh Cohen, Clay Wilton, Helen Anander, and Tyler Bassett, developed this modeling tool, and they published this paper assessing the ecological need for prescribed fire in Michigan using GIS-based multi-criteria decision analysis. And this was to sort of, because resources for fire are so limited and so many places need it, they developed this as a way to sort of assist in the decision-making process, but also really put a number on how much of our public land, our state land, needs fire and how frequently it should be burned. So it's a really useful tool. The basic concept is this. This is a sort of imagery of a game area. So it's these public lands are broken up into stands for an inventory process. And so the inventory process, basically somebody walks a transect through one of these stands, records the vegetation, gives abundance, and then classifies it based on what natural community it most closely fits, right? So this stand concept is applied all over public lands, game areas, national or state forests. And so what we can do is use those stands as the basic unit for this model, right? So we plug in the vegetation information in these stands. We look at landscape scale factors also, so physiographic region, what the area was around 1800s, different geological considerations. Within the stand, based on vegetation, we look at fire frequency, aspect, slope, what type of natural community it is, stand age, and if there are any rare species associated with fire-dependent systems. And we can plug that all into a model to give us this. It's essentially an output that creates this stand level data to help prioritize where to apply prescribed fire. This spatial representation is available at multiple scales, and we have provided summary graphics and statistics by areas of interest. So for example, statewide, we sort of have this temperature map where you can see in the upper peninsula, a lot of blue, not as much fire adapted areas on state land. But as we get to Southwest Michigan, you can see there are a lot of areas that in the state game areas that support natural communities with a high fire need. So it's a really useful tool for public land managers to understand, okay, this is where I should be putting fire, and this is how frequently I should be applying it. I saw this output, and it became clear that it could be applied to large blocks of public land with stand level inventory data. And it provides the perfect framework because it looks at all the things I would be using to hunt for barrens, like maybe undocumented systems. If this model really provided the perfect framework for identifying undocumented fire adapted systems in areas that have not been surveyed. So there are huge amounts of national forest that MNFI ecologists simply haven't been able to survey. And so because they have stand data, it seemed the perfect opportunity. And so we reached out. I have some counterparts in the Cadillac Manistee District of the Huron-Manistee National Forest. And I said, hey, we've got this approach. We want to see if we can find some of your fire adapted systems. So we were working in this area, and it's about 1 million acres in the lower peninsula. And they have actually been really interested in identifying barrens areas already. So this is an area where they had previously worked, where they had done a couple of prescribed fires, and they thinned, and they almost, as soon as the work was completed, they started having turtles nest there. So these turtles that they had been tracking changed their nesting behavior almost immediately. And so they realized that this type of habitat work would have a lot of benefits for some of the species that they're working to protect. So they were all about it. Now, we've got this huge landscape. This is an elevation model that shows like the landforms, and these are sort of deep outwash sands that were deposited as the glaciers were receding. So deep outwash sands mean a lot of fire dependent systems, right? So here's some circa 1800 map. And what we can see is there were a lot of white pine, red pine forests, and these sort of cream colored areas here, those are pine barrens, and then there are some areas of oak pine barrens in there too. So we've got clearly a lot of systems throughout this district that supported, that were strongly influenced by fire. And historically, fire would have been applied primarily by indigenous peoples. They would have been burning for a number of reasons: to promote vegetation, different sort of strategies for hunting. They also would have applied fire to attract and influence how game moved and behaved on this landscape. So there were large herds of elk there, big herbivores that sort of respond positively to fire. There were also concentrations of passenger pigeon roosting areas in this district. So all of these worked together to sort of create historically this shifting mosaic where over huge periods of time, or maybe centuries, you would get these burns. They would kind of expand these savanna or grassland systems, and then slowly over time, as the pattern of fire application changed or herbivory behavior changed, you'd get these sort of shifting mosaics of barrens in these dry forest conditions. Well, as European settlement marched across the landscape, the factors that were driving this shifting mosaic stopped. And so our modern landscape is not really compatible. Our modern social landscape is not as compatible with this shifting mosaic. And I kind of like to say, when in the game of ecological musical chairs, when the music stopped, the sort of systems were kind of stuck in place, and then immediately began to kind of convert to forest. So we've lost a lot of these systems, and we need a way to find it. Well, this model turned out to be an approach that I wanted to try. So kind of help us, by using all these different aspects, help us narrow our search. And so we applied the fire model to the Cadillac Manistee District, and we came up with these stands. So the red, obviously more fire adapted, orange, high fire need, and then all the way down to blue, where, fire historically probably wasn't much of a factor. And then we used aerial imagery interpretation to kind of find spots that seem to have what we were looking for. And what we were looking for was remaining high quality natural communities. So these natural communities, they're an assemblage of interacting plants and animals and other organisms that repeatedly occur across the landscape. And they're predominantly structured by natural processes rather than modern anthropogenic disturbances. And ecological acknowledgement. So historically, indigenous peoples were an integral part of Michigan's natural communities. Many community types were dependent on native management practices, such as the application of cultural fire, wildlife management, and harvesting of plant materials. Their interactions were widespread, sophisticated, and central to maintaining historic abundances of biodiversity. Indigenous peoples and their cultural practices were and are integral parts of the natural ecosystems that we strive to protect. And our definition of natural communities recognizes that. This natural community classification, it divides the complex natural history of Michigan into the complex natural landscape of Michigan into easily understood and describable components. This classification creates a common language about an area's native biodiversity and ecological context. And so as we're documenting these, that map shows a transect that I walked to, as we cover the landscape, we're looking for the best of what remains. When we're ranking these, we're looking for size, condition, under condition, anthropogenic disturbance. Have these been severely disturbed, or are they pretty much intact? We're looking for things like invasive species. We provide a landscape rank. So is this a small remnant in the middle of a cornfield, or is it a high quality remnant in a massive natural landscape? And then we compile all those for an overall rank. We give it A through D, so excellent through poor. And during this process, we're describing vegetation, so canopy composition and structure. We look at tree size and age, the understory and the shrub layers, and herbaceous vegetation as well. And then describe any variation within those different strata. We look at abiotic factors like soils, landform, different ecological processes, threats to the system, and then we make management recommendations. So we're crossing the whole landscape, looking for these places and then describing what we find. And it ends up looking like this. So we map these communities and then we maintain their location and condition in this statewide geodatabase. Well, how did it do? So we created this model. We searched for natural communities. We spent 14 days looking for sites based on site leads from this model. How did it do? Well, it turns out it was extremely useful for directing field surveys, and it resulted in the documentation of several fire-dependent natural communities. We had dry sand prairies. These were really cool sites. Some of the species here is Coreopsis lanceolata, wood lily, just one of our most beautiful native flowers, butterfly weed, obviously a fan favorite. We found pine barrens. So these are sort of savanna systems with pine in the canopy, especially you can see this old open grown red pine. We have different service berries and choke cherries in the subcanopy or the shrub layer here, often with jack pine, and then dominated by native grasses, big blue stem, little blue stem, hair grass. We also found, this was really unexpected, we also found a really interesting example of a hillside prairie above the steep slopes of the Pine River. So we had these extremely tall, very steep slopes that were just loaded with a lot of the prairie indicator species. So big blue stem, little blue stem here. This system is a little bit more common. Well, it's prevalent for the most part in the southern half of the Lower Peninsula. And it's maintained by these steep slopes intersecting with the river, and the river causes this erosion, and the slope sloughs off in places, and then it's recolonized by a lot of these sort of prairie species. It's a really interesting system, and I think only 14 have ever been documented in the state, and a lot of them have been lost to development lately. This one, while there are several great openings to it, is also suffering from some pretty intense abuse. Kayakers will actually, you can see these kayaks at the bottom, they will park their boats at the bottom, run up the top, and sometimes drag their canoes or kayaks up and then ride them back down into the river. So it's extremely damaging for one of our rarest natural community types, but there's still a lot of good places left to it. And you know, when we brought it to their attention, we said, hey, maybe put some signs up or something, because you know, it's a high priority for conservation planners. Very beautiful scenery though, just incredible views. It was a real joy to find. So here's the distribution of the community type, the hillside prairie across the state. You can see infrequent in the lower part of the state, and then there are a few examples along the Menominee River, but it was absent here. So this project put a new system on a map in an area that it hadn't been found before, and that's always really exciting work for me. Some cool species that we found up there: Lathyrus venosus, Anticlea elegans. And then this one, I actually couldn't figure out what it was at first. I mean, there wasn't a lot to go on, but I'm like, so, okay, some weird legume. Polynesia dodecandra, turns out not even a legume. I had never seen this plant before. I guess it's not all that rare, but it had just never come across my radar. But so it was new to me. I recognize that this is a little botanically oriented, and I'm sticking with the scientific names. Hoping you'll forgive me. I shared some of this work with some folks at the U of M herbarium, and I just decided to stick with the scientific name. So if this isn't a safe place for it, I don't know where it is. So we would compile these species lists for every natural community type. And you can see in these columns over here, we've got the C-values, coefficient of conservatism. So like that's on a scale of 0 to 10, 0 being an invasive or weed that basically grows anywhere, 10 being a really conservative species that has a high fidelity to undisturbed spaces. So we compile all those species lists into a floristic quality assessment, and this churns out how many species we have, what proportion are native, and then gives us an FQI. This FQI is really a fun score. Anything that gets a 35 or higher is considered of conservation significance. A score of like 50 is extremely important for protecting native biodiversity in Michigan. So a score of 46 is, especially on such a small site, is kind of bonkers. At the top, it was really interesting. The top band of this hillside prairie had these concentrations of barren species kind of clinging to the edge. So you have this narrow band of barren vegetation, often adjacent to the tops of the hillside prairie, where like the canopy just hadn't closed in. So all that vegetation characteristic of the barrens community types was still persistent. Another really cool site was this wet music sand prairie. So these wet music sand prairies I think of as hydroxeric, right? So hydro in the late winter, early spring, they can be inundated with a couple feet of water. And then xeric, because they're deep sands, they drain really fast. And so you get this sort of double edge, maintaining them as open and preventing tree encroachment, right? So you have to have both species that kind of can handle these wetland conditions, but also handle the intense drought. Really beautiful system. I kept these in. So some of the interesting grass species, and this one was actually one of the most dominant, is Dischampsia cespitosa. Another one, prairie cordgrass, spartina, Panicum virgatum, kind of everybody's favorite. And this is really where I see switchgrass. Panicum virgatum is these wet systems, and sometimes in dunes, but primarily in these wetter systems. I see it a lot now in plantings and upland areas, but this is kind of, when I'm thinking natural settings for Panicum, this is really what I think of. Some Dicanthelium lindheimeri was a dominant, and then blue joint, and then even big blue throughout. So real fascinating grasses, cool sedges, Carex vesicaria, stricta, kind of the classic tussock sedge, Carex pellida, Buxbaumii, which is just fun to say, and then Rhynchospora capitulata. So some cool sedges, cool sedge diversity throughout. It was definitely a challenge. I spent a lot of time just keying piles of plants that I collected here just to make sure I got it right. Great forbs. Some of the indicator species of these wet music sand prairies up here was Lobelia spicata, and then oddly this little Inothera perennis, like a little evening primrose, really small, diminutive, cute little thing. One of the real showstoppers for me was this Asclepias hurtella, though, this tall green milkweed. So I think state endangered, and this ended up being, a new county record for it and the northernmost population in the state. So kind of an interesting little station for it up there. So that was a huge find. Was really pumped about that. Other kind of common forbs in this wet music sand prairie: Iris versicolor, Lysomachia quadrifolia, Solidega rugosa, Cicericium angustifolium, and then Viola lanceolata. Just gorgeous, so much fun to survey. 149 total species, 143 native, and then a really high FQI of 53.7. So definitely a really important site, and one that it felt great to put on the radar for the managers up there. They kind of knew about it, but I don't think, they just had never had such a detailed assessment of the site done. So I think a lot of people were really excited about it. Other important finds from our surveys, these oak pine barrens. So you can see these wide open situations with these kind of open grown oaks. These oaks are going to be about 120 to 150 years old. The one on the left there, dominated by hairgrass, Avenella flexuosa, a lot of pen sedge, sometimes little blue and big blue. Cool forbs in these oak pine barrens, liatris, polygama, and then calistigia, the white flower there, and then melonpyron. Other flowers or forbs, viola, and then we had lithospermum and Helianthus occidentalis, western sunflowers. So those ended up being pretty characteristic of the barrens remnants that we found. Again, wide open grown oaks, specifically white oak, and you can see the white pine in the back, kind of lower branching, real characteristic of this open barren situation. But also a lot of these had dense undergrowth of oaks coming in. So while you could still see the structure in a lot of places, it also is clear that it wouldn't be an open barrens much longer without some intervention. So you kind of got the feeling that the forest was constricting around a lot of these openings. Those were the highlights, but the results, we found a lot of great places. We found 16 previously undocumented natural communities, the hillside prairie, wet mesic sand prairies, oak pine barrens, and then dry sand prairies too. We updated 2 records for 2 previously documented natural communities too. So it was extremely fruitful for a pilot study. The conditions of the remnants were really interesting. Generally, there is an overwhelming abundance of pen sedge, Carex pennsylvanica, and hairgrass. And this is likely due to severe historic disturbance, right? The land was completely logged, cleared, and then there were these sort of infamous slash fires following the logging. Since then, there's been protracted fire suppression. So these systems historically burned probably pretty frequently. And then there's been intense pressure from deer and potentially a loss of elk. So elk were definitely here. They were probably in sufficiently large numbers to impact these systems. And what's fascinating is they eat more woody growth than deer, and they also eat sedges. And they're so big that they tear up these dense sedge thatches so that other things can grow. So it seems like in the absence of these herbivores that could really impact the sedge and grass layer, sedge and like it's just completely taken over, and you combine that with intense deer herbivory and you've lost a lot of forbs, and woody encroachment is really coming in. Now, the prevalence of graminoids and the similar appearance of grasses in general gave a uniform appearance to much of the landscape. So it could be really difficult to tell the difference between a high quality remnant and just sort of an opening in the woods. And it required a familiarity with Michigan's flora, especially grasses, and each species' degree of affinity for undisturbed habitat. And that was critical for recognizing remnants. So this is a picture of a spot that had really high grass diversity. And it's admittedly, it doesn't look a whole lot different from this, which is only pen sedge. Some of the species that were really important to key in on: Bromus colmii, Piptachedium, Avanasium, and Dicanthelium xanthophyzum. So being able to recognize these and other species for sure was really important for identifying spots that kind of had that recoverable barrens pulse. We compiled this list of kind of indicator species so that they could take it, familiarize themselves with these species, and identify remnants when they were in them. Grasses, really, for your most conservative species of a C-value 8 or higher, grasses were 38% of that species. There were a lot of forbs. 47% of your more conservative indicator species are forbs, but the thing is that forbs were at such low abundance that even though they were diverse, they were often hard to detect. And it was really grasses that were just there. They were so much more abundant that it was important to recognize the indicator species to know when you're in one of these systems. And then there were a couple of conservative shrubs that were really important to key in on as well. Another takeaway from this project, the superabundance of deer across the region has substantially decreased the composition of forbs on the landscape. I would say we're at a crisis level. Major components of these communities are simply functionally extinct. They're just not reproducing. They're maintaining, but they're barely holding on. And I would say that's true for southern Michigan. It's an incredible problem. And this shifting baseline it just makes it hard to understand what we've actually lost. In the last 30 years, it's just had to have been catastrophic. Through this process, I kept asking myself, well, why have these remnants lingered? Why are they still here? So for example, this is a wet music sand prairie, and it followed this little drainage. You can see this little drainage on this elevation map. And this in the winter and spring fills up with meltwater. And so trees can't encroach it. And in the late summer, it's bone dry. And so historically, the species that are present here were all over the landscape. But in a landscape where fire's been suppressed, where forests have grown into these savanna areas, all these species that require these open conditions are relegated to little spots that can fight back. So the small drainage, the hillside prairie, the south-facing aspect was too hot for it, slowed the encroachment of trees. Also, you had that erosion where parts of the hillside would slough off from time to time, maintaining these open conditions, right? So you had this additional factor keeping it open. Same with the barrens at the top of the hillside prairie. So there was just enough light to get in where it couldn't close at the top there. And that allowed the persistence of these barren species to extend into sort of this area that's converting to forest. So you have it kind of clinging to the landscape in certain places. Here, you can see these depressions here. So these are maybe where ice blocks fell off, a retreating glacier, floodwaters deposited sands. Where the glacier was, the sands couldn't get deposited, or where the ice block was, the sands wouldn't get deposited. The ice block melts, that depression stays there. Well, these depressions function as frost pockets. So you get late season frosts, sometimes through June even, and that really slows growth. So while much of the landscape historically looked like this, that sort of trapping of cold air prevented the full encroachment of the forest into these areas. And these are now dry sand prairies. Well, what to do? How do we recover these? And we're trying to figure out how to sort of build a framework around it. And the shifting mosaic was how these were established and maintained for millennia. But we came upon this idea, and it's the dynamic core concept. And to frame management approaches, we suggest abandoning that shifting mosaic concept and instead focus on these areas where barrens and prairies persist. And I started calling these focal areas dynamic cores. And they're the nuclei of the recoverable fire-dependent systems, and their recognition and stewardship are critical for maintaining diverse assemblages of vegetation on the landscape. So we have to find these cores to basically rescue. Let that shifting mosaic go, at least for now, while we're in this sort of core rescue phase. So, for example, we've got these dry sand prairies down here in blue. We've got this oak pine barrens in purple. What does this management approach that we're suggesting look like? So phase one is core rescue. We identify these places and stabilize remnants by reversing this collapse. And we develop a large project area. So this would be a potential burn unit where we're burning much more of the landscape, kind of following existing features like roads, property boundaries, where where we have to, and things like that, but trying to create a much bigger landscape. So these remnants were part of a huge landscape, and we're only finding the scraps that remain in these small areas. So we don't want to just like focus on these small areas that we find. We want to sort of rehabilitate a much broader area. So phase part two, or the next idea that I was really focused on, is protecting these legacy trees. Things like red pine, old red pine, and old white oak. These are your most fire resilient species. They were definitely like the anchors of these systems that saw high fire frequency, where you have jack pine and black oak that have really come in. They're much less resilient to these high fire frequency approaches. And I call these old white oaks, these 150-year-old white oaks and these 150-year-old red pines, as sort of a genetic bridge from now to the landscape that we're trying to reestablish. These trees established under the conditions that we're trying to bring back. And if you put a fire through here, all this jack pine under this white oak is going to torch it. If you're not careful, you're going to lose some very important genetic material that served the landscape historically, the landscape that we're trying to maintain. So these trees are often the first ones that are cut when people want to do any type of forestry work, but they're the ones that need to remain on the landscape. So we have to sort of take care of them ahead of the next fire, whatever that looks like. Removing duff from the base, spraying down fires that are kind of cooking the roots during a fire, or removing ladder fuels or nearby trees that would potentially damage them. Another idea in this phase one is protect ecotones. So these ecotones are sort of, you see this, there's on the right, we've got this barrens that transitions to an intermittent wetland. Well, this band in the middle is sort of a band of wet mesic sand prairie, extraordinarily diverse. But often this is where people want to put a fire line, because you don't want to mess with it. A lot of approaches to fire, you have to have a hard line. You can't just burn into a wetland and let it go out in the wetland. But this ends up cutting, like sort of amputating some of the most important areas that, like these species, as water levels fluctuate over long periods of drought and different frequencies of fire, the species that are in this wet mesic sand prairie actually can sort of reseed this pine barrens. Many of the species that would grow in the barrens are still in this band. And by setting these fire lines here, you're destroying one of your best resources to sort of revegetate the landscape with the species you want. So protect the ecotone. Same thing, I see these openings here where it transitions from forest to barrens or even open dry sand prairie, and they just put a fire line because it's easy. But these systems they used to be so much bigger and more dynamic. And so when you put a fire line at the edge, you lose some of your more diverse zonation of the system, but also you're basically just saying, this is it. You'll never be bigger than this. And so you protect these ecotones, but do more than just the remnant, do a much broader part of the landscape. Also start at the bottom. There's this sort of, if you build it, they will come mentality where, oh, what's a savanna look like? What's this barren structure that we're aiming for? 30%, 50% canopy, let's just create it. And that's the top-down approach. And what happens when you do this, when you just punch holes in the canopy without starting at the bottom, you get this wall of oak regeneration, and it completely suppresses and kills all of your characteristic barrens or herbaceous vegetation, right? So you release all these saplings, and then it's just a hellish, unmanageable wall of woody regrowth. You have to start at the bottom with these frequent, low intensity, low severity burns before thinning. And for another reason, because you don't know which trees are going to survive fire. A lot of them can handle fire. A lot of species are classic fire adapted species, but that doesn't mean all the individuals can handle it, right? So a lot of people will just thin and then burn, and you have no idea if the trees you left are going to handle fire or die after the first burn or after a couple. So here's a black oak part of fire adapted systems for sure. But you see, it's already got one fire scar. It's been burned a second time. How many more fires will this thing be able to handle? This would be the one to take, right? One that shows a lot of damage after these initial fires. And then you leave the trees that are going to be more resilient. A lot of times what I've seen is people thin, they burn, and then they lose a lot of the trees that remain. And then all of a sudden you've overshot and you've got almost no canopy remaining. And this is a process. It took a long time to become forested from a barrens, and it should take a long time to kind of come back from forest to barrens, or at least sort of incrementally, instead of just like, well, just do it as fast as we can because we have funding this year and we just have to do it all right now. And you'll do more damage than good, I think. So phase 2, core rescue. Phase 3, expand the cores. So slowly expand and connect openings through fire and forestry. Initiate expansion of openings, work the edges is what I've been saying. So here we've got a dry sand prairie, and they've been kind of slowly expanding the opening by removing the understory and a couple overstory trees for sure, as they apply fire. So it's this gradual approach, expanding the openings, working the edges, identify and expand new cores in the project area. So we drew that big boundary, not just the remnants, but we drew a big boundary. Hopefully we're putting several fires on the ground, and hopefully new cores will pop up in that project area, areas that maybe we didn't identify in the first run through. And ideally they're going to be close to your other barrens. You can connect these, try to create sort of these corridor openings to expand your existing cores and connect them to new core areas that have sort of popped up. And then continue to apply fire at a rate of about 3 to 5 burns per decade. And I don't know exactly the number, but that's from the literature. That's a pretty good number to approach. Even if it's 3 burns per decade, that's really where you want to be hitting. And avoid the sunk cost fallacy, right? Some of these areas, you look at a district the size of the Cadillac Manistee, right? 250,000 acres. If you have 10 project areas that are all 1,000 acres or so, they're not all going to be winners. And we really need to focus the effort and resources on the most important areas that are showing the response we're looking for. Finally, phase 3, shift the mosaic. I mean, shifting mosaic hypothesis, that concept really did govern this landscape. And once we've kind of stabilized it, I believe we can get it back. And we want to shift these openings within a stable area. So you can thin larger areas. Once you have these sort of resilient openings that have reversed that momentum and are now expanding, now you can thin areas around it. I don't think you have to be as delicate. Once we kind of have this landscape that's conditioned to this management approach, I think it'll respond really positively. And then you can kind of have this, if you build it, they will come mentality, but all these other places have to be in order. And I think you can get away with less frequent burns, right? So initially it's triage. It's like, okay, what are these places that we have? Fire can be a really valuable tool to sort of reverse that momentum, stabilize the landscape. And then I think you can do less frequent maintenance burns. And maybe that looks like 1 to 2 burns per decade, but we don't know for sure. And what I'm talking about here in this landscape doesn't necessarily apply to every landscape for everybody that's watching. And we need long-term monitoring so we can adjust our decision-making. And to be honest, this monitoring applies to every phase of this, right? We should be monitoring before we're doing anything. We don't invest enough in monitoring, and it should be definitely a critical part of every phase. So as we're going through this, we're looking at how vegetation is shifting. And I really want to hammer that home, because without it, there's just a little bit too much uncertainty. But careful monitoring, long-term transects, photo monitoring, things like that, really understanding how this management approach impacts those high C plants, your most conservative species. Are they responding well to this frequent fire application, or are you losing all your most conservative species? You can only answer those questions with long-term monitoring. Which approach, you know, worked? Was it the fall fire? Was it the, gradual thinning, or what? Monitoring, monitoring, monitoring. All right, I'll move on. So some take-home points. The distinction between shifting mosaic and dynamic core is important because it emphasizes the careful recognition of the cores of recoverable habitat. Our dynamic core concept requires a management approach based on recognizing, protecting, and expanding the recoverable nuclei with a ground up and site-specific approach. And we contrast this to the shifting mosaic approach, by which a manager might recreate a barren structure in a forested area and then encourage composition to develop through fire and mechanical work. That build it, if you build it, they will come approach, or this top-down and site unspecific approach. And this is what we're seeing a lot of. This is what we're seeing a lot of. And this is that sort of top-down approach. So where do we go from here? This was essentially a pilot study. We covered this ground really well, but as you can see, there's a lot of other areas that look pretty tasty in this Cadillac Manistee District. So we actually got a second wave of this project funded. So we're going to do it. We're going to complete the Cadman district, and then we're also going to go to Mayo, which is on the east part of the state. A lot of pine barrens there. So this is really exciting. They like the work. They've kind of shifted management approaches around a lot of places on this district. And as you like, so this is a map of the gold is national forest and the green is state forest. There's a ton, millions of acres of state forest lands, and we wanted to apply it. And we actually just this year got a project funded. So we're going to go to 2 different districts in the northern lower and hunt barrens there too. So this work is just rapidly expanding. It's really exciting, and I think there's a lot of good stuff to come from it. Yeah, and that's really important, because what we're seeing, it couldn't come at a better time. With these areas that haven't been burned in a while, you're getting a lot of black oak coming in. Black oak is extremely susceptible to oak wilt, and in response to that, we're seeing a lot of this simply conversion of these historically barren sites to plantation, where they're herbiciding and just planting to red pine, because then you don't have to deal with oak wilt. And we're seeing a lot of problematic management approaches, and you can't cut your way out of oak wilt either, right? So you cut it and you just get this dense wall, and now you have this landscape that's increasingly susceptible to oak wilt. You've got a landscape that's increasingly susceptible to catastrophic wildfires, because these sites that historically burned actually are more resilient to sort of the catastrophic wildfires. And so we really feel that this approach to low intensity management of these systems is going to give you a much more resilient landscape, and one, honestly, that can sort of handle forestry. So you ideally, in a lot of places, will be able to thin, burn, and create and expand these barren settings forever. So we really think that this is the best approach to a more resilient landscape, where we stop hemorrhaging biodiversity and really start protecting our incredible natural resources. This is all available in a report on our website. You can just search, I think, our 2022 reports. This is what it looks like. I'd like to thank our partners, Derek Cross, Bob Sanders, Chris Hoving, Mike Donovan, and Mark Sargent in the DNR. In the Huron-Manistee, Brooke Owens, Rich Corner, Scott Warson, and Pat Larman. My colleagues that really helped this work, Josh Cohen, our lead ecologist, Tyler Bassett, one of our lead botanists, Helen Inander, our GIS expert, and then Paul Schilke. He's one of our botanists and did a lot of great work on this too. And with that, I'll open it up to any questions.
Thank you so much. Wow, that is pretty incredible to watch the whole journey of and follow along with the thought process in developing these management strategies. So I wanted to there were a couple questions that it seemed like multiple people were interested in, and I know that some of this information is available for folks to revisit. But one of the things that was asked is if you could overview once again the different criteria other than just the fire adaptation in plants that are used to determine fire suitability, and also if you could speak to how you weight those different factors when using the model to determine, the best sites.
So I did not make the model. I saw its application, but I I did not develop the model, and I'm certainly not a specialist in that. But some of the different factors they did we assign a natural community type to each one of those approximately, the best that we can based on the vegetation that's there. From there, there's a lot of literature based that gives us an idea of fire frequency in these different landscapes. So we look at that. We look at what the circa 1800 vegetation was, right? So we have these notes from the original surveyors, and so we can kind of get a sense of what it was historically. And so we also look at species lists for these inventories because they have tree composition there. And so each one of those trees, the folks that developed the literature or the model did a literature review on all the species and came up with sort of, what's their affinity for fire adapted systems. So all of these factors, they looked at soil aspect, all of these factors went into compiling a score. And it's five bins from high fire need all the way down to basically a lake with no fire need. And it's more involved than that. And I threw that slide up with the title of their paper, and I think it's open. And so if you have deeper questions, I would go to that because I just stole their idea, or I just used it as a tool for my own
Yeah.
savanna hunting.
No, that makes a lot of sense. Thank you for that. Another question that had come up, and it was discussed a little bit in the chat among folks, is the question of invasive species, and are you ever concerned about invasive species that reestablish themselves just as well or even better than some of the native species that you're trying to support through burning? And if so, is there any approach to like pre-treatment of those invasives prior to burning, or post monitoring? Just like, how does the idea of invasive species factor into how you approach fire, and whether or not it even helps some of the invasive species?
So the wet music sand prairies, I was concerned about reed canary grass. And I brought it up, and some of my recommendations were it was very, very localized, small patches, but to treat it, immediately as like a top priority thing. So there weren't in the wetlands, there weren't a lot of issues with that. In the uplands, there were a couple that were insidious. Poa pratensis, this ubiquitous grass, you almost can't even perceive it. But in some areas, it was like the most abundant grass. And to be honest, I have seen it bounce back after, I've seen it respond positively to fire, but also I have no idea how to treat it. And I feel like a lot of people have no idea how to treat it. So it's this cool season grass that is extremely aggressive rhizomatous, and it's everywhere. People have been planting it for 100 years, and you almost can't even see it. You can't even detect that it's there. So I do think and that was one thing that I talked about is in the report, is that I'm concerned about it. I don't know what to do about it. There's some work out of Illinois, I think I cited a paper, but there are also native POAs that you don't want getting impacted, and there are other native cool season grasses. And so do you just burn and just hope that on the balance it's a positive? Other than that, there weren't really a lot of invasives that couldn't be treated with just some spot spraying, or however you want to approach it. I'm not an expert in invasive species management, so I feel like maybe some SISMA folks might kind of cringe at what I don't want to get it wrong. And I just hope that sort of the land managers we're working with know what they're doing with that, right? I'm not a certified pesticide applicator, but I just try to draw attention to the species where they're at, and if there are sort of any resources I can help out with. But that POA did freak me out, because honestly, it was only perceivable for like a 3-week period during these surveys, and then after that, it just kind of, it goes dormant, or it just looks like every other grass, and you just can't even tell it's there. So that's a good question.
Thank you so much. And I'm so sorry to folks that we can't get to all of the questions, but I'll be sure to forward them to Jesse, and also, maybe some opportunities to reach out to Jesse with additional questions. But thank you so very much. It was such a healthy conversation in the chat and in the Q&A. So we really, really appreciate you for coming here and being a part of this presentation. With that, I would like to just take us into our outro. So let me just do that for you. So once again, I'd like to remind folks that advanced registration discount for the Stewardship Network Conference 2024 ends on January 21st. So we encourage you to register before that date to take advantage of the great discounts that we have to offer. And I'd like to once again welcome the Columbia River Gorge Stewardship Network. We are so excited to have this new member community as a part of our network. And I really encourage folks that are interested in having a community in their geographic area, or if you know folks that might be interested in coming into the fold, please do reach out to us. We would love to have you be a part of this network. We encourage you to become a regular at these monthly webcasts. So again, the second Wednesday of every month at the Eastern Time Zone's noon hour. So register for the episodes that are coming up so that you can get a reminder. We always send an email reminder the morning of, and we want to show you a couple of the great presentations that we have coming up here. So in February 2024, we have Not So Different: Using Bugs to Fight Apathy and Inspire Empathy with Christy Reddick and Jessica Honecker, the Bug Chicks. This has been a highly anticipated presentation for quite some time, so we hope that you'll join us for that one. Next, in March of 2024, we have Returning the Wild to the Wilderness: Loss, Legacy, and New Opportunity with Thomas Keller of the Pennsylvania Game Commission. Really excited for that next one. That's a couple months out, but again, you can register for these online at stewardshipnetwork.org/webcast, and just register in advance and you'll get a reminder so you don't have to think about it. And we have in April of 2024, Climate Change, Michigan, and the Bigger Picture with Jeff Masters of Yale Climate Connections. And I know that topic will be interesting to a lot of the folks we have at the Stewardship Network. We have a lot of Michigan folks within our network, and also looking at the bigger picture about how the state of Michigan is impacted by climate change and how those lessons can be applied to other states and geographies as well. So with that, once again, thank you all so very much for being here. My name is Rob Luzinski with the Stewardship Network, and we hope you have a wonderful rest of your day. Take care.